So this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and please participate. But again, these are being recorded, so it's really important that you do not share personal information during the session. All right? So at this point, you should have your ticket open. Again, if you're coming in a little bit later, that's totally fine. The ticket is in the chat box for you. So click that link to the ticket and then scroll down, enter the password that you see in the chat box. All right, make sure you spell it correctly. Make sure you use capitals as necessary. And then click Start Quiz so that you could open it up. Again, we don't need to do anything in it yet. I will give you all the answers as we go through class. So leave it blank for now. I will be giving you the answers. Now, I do want to remind you, especially our new students who just started yesterday, that the password is only provided in person at the live class, and this counts for 10% of your grade. So it's really important that you're actually attending live class. If for some reason you have a full-time job or something, please let me know. We can go ahead and work something out, okay? In an email. Don't do that right now. Just go ahead and email me. Speaking of which, here's my email. Here's my phone number. All right, contact information is right there. Definitely contact me if you're having any issues. Remember that you do get 5 attempts on every assignment. So if you don't, yes, no problem, Mariana. Thanks for letting me know. Remember that if you don't do well on something the first time, just try again, right? You get lots of attempts. If you need help, you can come to support sessions, those optional sessions that you see on Tuesday, Wednesday, and Thursday. Come to those support sessions. I can definitely help you out and help you do well on every assignment. So whatever assignment you need, I'm there for you, and I will go through it with you as you need. All right? Annalise, you need to capitalize the J. Okay, so just try that again. And then if you still have issues, you can email me, okay? Cool. All right, so today we are working on friction and gravity. Tomorrow we'll talk a little bit about gravity, some motion, forces, and vectors, how all those things are related. Thursday we will be doing a lab together for the net force lab. So this is actually more like a kind of worksheet that you fill out. This is not exactly the same as our old labs. And then Unit 3, we will be having a game day. I don't know, Andrew, do you guys enjoy the Kahoots? We can keep on doing the Kahoots. I can try to find something new if you guys want. But if you're enjoying them, then we'll keep on doing them. Love it. I love them too. So I'm glad you guys are having fun with them. Cool. All right. So cohorts 2 students, please make sure that you'll be hearing about this. I know you're just starting, so you guys probably have a lot of stuff to do. But I do want you to be aware that every quarter, our students are required to take the STAR 360 math and reading assessments. And again, these are completed every quarter. They are 10% of every single course grade. So in my class, they're 50 points because they're 10% of my course grade. But they're big points in every class. And obviously, I am not a math or a reading teacher. I'm a science teacher, but it still counts as a grade in my class. Smiley face if that makes sense. It counts as a grade in every class. PE, tech, econ, every single class. Okay, so it's really important that you do both of them. You have to make sure you do, but it's not the second quarter yet. Sorry, we have students who start 2 weeks late. So I'm currently talking to those new students, Brianna. So make sure you do both math and reading, okay? If you see where it says early literacy, you're gonna ignore early literacy. And when you click on the test, it'll ask you to choose a teacher. It doesn't matter which teacher you choose, you can choose any teacher. Now, I want you to be aware, especially new students, that this grade that you're getting in each class, it's for as long as you complete it, okay? So as long as you get it done, you'll get all those points, all of them. Okay, but you still want to try to do your best because your performance does affect the number of required live sessions you have to go to. So, so in a week, we're going to be taking a look at your scores on STAR 360 as well as your grades in your classes. And based on those, it's going to determine if you need to be going to more live sessions or less live sessions. So if you want to be going to less live sessions, definitely do your best to do well. Okay, and make sure you're passing your classes by Wednesday, okay? Smiley faces if that makes sense. Smiley faces if that makes sense. Looking good. Perfect. Okay. So the instructions are in your grade book. Okay, so if you go to your grade book and you scroll down to STAR 360, the instructions are there for you. But just to give you a heads up, you'll log into this website. okay? And then you'll enter your username, which is just your student ID. If you don't know your student ID, please email or text me. I can get that to you. Okay, so you'll send me, so you'll enter your student ID, and then your password is just your first name with the last 3 digits of your ID, right? So if your first name is John, and you take a look at this ID up here, the last 3 digits are 456, then your password would be John456. Okay, everyone give me a thumbs up if that makes sense. Again, this is just a refresher too. If you started school on time, you still should also make sure that this is done. Excellent, looking good, guys. Okay, so we are officially starting Unit 3, talking about the application of forces. All right, so we're looking at forces like friction, gravity. All right, we'll also talk a little bit about vectors, and we'll learn about force in terms of vectors, and that's a whole bunch of what our God is going, or sorry, what, sorry, I was reading your comment, Kim, at the same time. That's a whole bunch of what our lab is going to be on Thursday, okay? So this is a super short unit, all right, but I will be helping you out. And really, they're not scary, Kim. We're really just going over the basics of vectors. I'm not having you do anything crazy like multiply vectors, okay? I know, right? That brings me back to my, like, physics days as well in high school and college, so I remember that. All right, so, oh, nice. Thank you, Annalise. So today's objective, we should be able to identify the different types of friction. We should explain the factors affecting gravity, and we should know the difference between mass and weight. So far, we've been talking a lot about mass and weight as kind of the same thing, but now we're going to learn how they're actually a little bit different from each other. Okay, so friction, all right, our mind map for today, this is a force that resists motion. All right, so it's resisting how you're moving things. And if it's between things that are moving, that's what's called kinetic friction. If it's between objects that are at rest, that's what's called static friction. So let's take a look at this. So friction, again, opposes the motion of an object. So it's going to be moving in the opposite direction of which way you're trying to move an object. So let's think about this. Let's say that I'm trying to move a refrigerator to the right. Which way do you guys think friction is going to work against me? If I'm trying to move sorry guys, I just lost for a moment. Okay, yeah, it's going to work against us in the opposite direction to the left, exactly. Now, there are 3 factors for friction, 3 things that we need to be taking a look at. So basically, what the object's made of, right? So an object made of sandpaper is going to have a lot more friction than an object made of ice. Smiley faces if that makes sense. Okay, so what an object's made of matters in terms of how slippery it is, how big or how little friction there is. Awesome, as well as its mass, okay? If you think about trying to push a tiny little box across the floor, it's not difficult, there's not a lot of friction. But the heavier the object gets, like a refrigerator, friction works a lot more against you, which is why it's so much harder to move those objects. And then also, obviously, what it's touching. So the matter that it's sitting on, the surface, also is important. Okay, so if they're both ice, right, or if one of them's rubber and one of them's wood, so on and so forth, okay? Now, again, remember that we've learned about Newton's first law. I know that happens when the audio lags and then speeds up. The matter, like the type of material, matter means the material. So the material that it's sitting on. Okay, so if it's sitting on ice, there's going to be less friction than if it's sitting on wood. Okay, that's what I meant. Good question. All right, so Newton's first law, we said, right, an object in motion will stay in motion forever with the same speed and direction forever, just keep on moving, unless it's acted on by an external force. But in real life, we know this is not true, right? If we push a box, does the box keep on moving forever? Once I stop pushing it, does it just keep on going? No, it eventually slows down. And the reason it eventually slows down is because of friction. Friction is this external force that we're talking about up here that is slowing them down. Okay, so this is why Newton's first law doesn't work in everyday life, because friction is an external force that is working on those objects. Okay, thumbs up if that makes sense. From your smiley face menu at the top of your participants panel, give me a thumbs up if that makes sense. Excellent, looking good. All right. So that being said, again, I talked a little bit about this, but I want you to be aware that, again, when there's more mass, this means that you're actually pressing the surfaces together with a lot more force, right? So think about, for example, if you are trying, sure, Tyson, try to focus though right now, please. Think about, for example, if you are trying to push an object, all right? If you just lightly hold the object and push it, it's pretty easy, right? Think about your phone, for example, on your table. If your hand is on top of it and you just lightly push it, it's not hard to push. But if you were to press down a whole lot more, it would get a lot more difficult to push that object, okay? So with more mass, we're pushing those surfaces together. You can see that right here. They're literally being squashed together more, and that's going to make it more difficult to move. It's going to increase the friction between those objects because they're actually touching each other more. Okay, any questions about this? Give me a green check if we feel good about this, red X if we have any questions. I know, this is very zoomed in. This is very, very zoomed in. Hopefully we're not driving on roads that actually look like this. Oh, Steve, remember appropriate language, school appropriate language. I appreciate it. Cool, perfect. No worries. All right. So there are two types of friction that we need to talk about. The first one is static friction. And do you guys know what's a synonym for the word static? What's a synonym for the word static? Tell me in the chat box. Do you guys know what a synonym for static is? We might not entirely know this because it's not often used in everyday language. I just want to see. Yeah, no, not exactly. So what static friction is, another word for static is actually still. Yeah, so we often talk about static electricity, which is like it's electricity that's happening even though the objects might not be touching each other and they might not be in motion. Yeah, so exactly, Kim. Yeah, so static means that an object is still. Okay, so static friction literally means that it's the force between two objects that are not moving. So this happens when you're trying to move an object and it's just not going. Okay, smiley faces, for example, I don't know, have you ever tried to push a car and the car just doesn't really move? All right, you guys know what I'm talking about? Or another big object, doesn't have to be a car, okay? Now, the thing is, you are applying a force to it, and therefore, there is friction working against you. So you might not see it in real life because nothing's moving, but that friction is still a really big force, okay? So this prevents an object at rest from moving across a surface. So before an object can even start moving, it first has to be able to overcome the static friction. Okay, so we have to be stronger than the static friction that's working against us to start an object moving. Okay, smiley faces if that makes sense, red X's if you're confused. Smiley faces if that makes sense, red X's. Okay, cool. Looking good. All right. Now, kinetic friction, on the other hand, now that we've overcome static friction and it started working, now it started moving, now we have what's called kinetic friction. So again, remember that eventually the object will slow down, right? The object isn't going to keep going forever. And that's because kinetic friction is slowing it down. All right, guys, in the chat box, please focus right now. All right, so this is going to be the force that resists the motion of the object as it's sliding. So we can see this right here, right? Our object is moving to the right, but friction, even though it's not as much friction, because again, obviously our object is moving, so we've overcome some of that friction. Even though it's not as much friction, it's still there. It's still slowing down our object. Okay? Let's make sure that this makes sense. So I want you to use your polling tools. So your green checks just turned into polling tools. Hold on, let me fix that. Green checks just turned into polling tools at the top. So go ahead, use the polling tool. Tell me what happens if I increase the mass of an object. What happens to the amount of friction? Annalise, friction is the result of if you zoom in really closely, surfaces are not perfectly smooth. And because surfaces are not perfectly smooth, it's literally like the little ridges are running into each other. Okay, so in real life, it's like if you imagine you have a set of mountains and you have another set of mountains flipped upside down and they tried to move against each other, they would kind of run into each other and block each other and prevent each other from moving. So that's what's happening microscopically if you were to zoom in really closely. Yeah, awesome. All right, I'm still waiting on a few more polls. So Andres and Elise, make sure you get that polling tool. Ciara, Dalen, Emilio, Haley, Jake, Jasmine, Johnny, Miranda, Melissa, Nadia. Use that polling tool at the very top. Awesome, and I see that most of us are giving the letter B, and that is true, right? Increasing the mass is going to increase the friction because we're literally going to squash the object together more. Awesome, all right, this is the answer to number 1. Remember, the order of the answers might be different, so you have to read carefully. Please give me a green check when you have number 1 saved. No problem, Elizabeth, you just got here in time for our first ticket item. So grab that link, open it up, enter the password, and answer number 1. Green checks, everyone. When you have number 1 saved, I'll go ahead and give you 20 more seconds. All right, let's get those green checks. Andrew, Angelina, Dolly. Sorry, Libby, I know you just joined us, but it's Johnny, Miranda, Melissa, Nadia. Get me those green checks, y'all. All right, looking good. Oh, sorry, guys, all right, looking good. Okay, perfect. So let's keep on going. So again, right, there are 2 types of friction, right? So the first type of friction prevents an object at rest from starting to move. What was this type of friction called? Tell me in the chat box again. Oh, no problem, Libby. That's a good idea. Yeah, take a picture if you guys ever need to, so you have it saved for later. Your quiz isn't working right away. All right, what kind of friction is the one that prevents an object from starting to move, right? The object is still. What was our synonym for still? Yes, I'm seeing it pop up in the chat box. Reinforce it in your own brain. Type it. Yes. Good. Yes, this is going to be static friction. Exactly. So this is going to be static friction. Sorry, guys. I'm being kicked right now. Static friction. Let's make sure I spell that right. And the other type of friction resists the motion of an object when it's already moving. So which one is already moving? And this word actually means motion. So yeah, I forgot to mention that. But yeah, the word kinetic actually already means motion. So it's literally friction for motion. Okay, so make sure you spell these correctly. These are the 2 blanks you need to fill in for number 2. Green checks when you have number 2 saved. Make sure you spell them correctly. Capitalization does not matter, just spelling. There we go. I'm going to go ahead and give you guys 30 seconds. Oh, no worries. I know that happens. All right, green checks, please, for number 2. Annalise, I see you're typing to me. Denali, I see you're typing to me too. Let me know if you guys are having any issues. Yeah, I know, right? It's helpful because these are also the same answers that are in your quiz, right? Yeah, I do want to remind you guys that if you are a new student, please be aware that these yellow boxes, not only are they the answers to the attendance ticket, but they also are very, very helpful for your quiz because it's the same information in your quiz for today. Awesome. Okay, yeah, no problem, Miranda. Just stay after class and I can go back to it for you. Cool. All right, let's keep on going. So the last thing that we need to talk about today, guys, is just gravity. So gravity, we're going to learn, increases with mass, and it's a force between masses. And we're also going to learn that it causes objects to accelerate. All right, so gravity, this is a force on an object that force an object exerts on another object based on its mass. So remember, mass is the amount of matter or the amount of stuff that everything is made of, whereas weight is going to be a measure of the force of gravity on an object's mass, which means it actually requires both mass and gravity. So this is the main difference between mass and weight, guys. So remember that no matter where I am in the entire universe, my mass is always the same because I'm always made of the same amount of stuff. Smiley faces, if that makes sense. No matter where I am, yeah, even if I'm in water, even if I'm in outer space, on the moon, on Earth, I am always made of the same amount of mass because mass is just your atoms, what you're made up of. No, so Annalise, that's true for weight, but not for mass. Okay, that's the difference. So mass, always the same. Just think of it as the amount of atoms. Your amount of atoms stay exactly the same no matter where you are in the universe. Now weight, this is what you're thinking about, Annalise. Oh, here you go, Denali. Weight is the measure of actual gravity on that mass. So weight, it does matter what gravity is around you, right? So on Earth, you weigh more than on the moon. That's why on the moon we can jump really high because there's not as much gravity. Can you give me a smiley face if that makes a little bit more sense? We're gonna actually prove this to ourselves in a moment, but I want to make sure that that's starting to make sense. Awesome. Okay, so weight, gravity matters. So weight we can also call the force of gravity. That's why when you see the equation, it either says W for weight or F with a little g for force of gravity. And what it is it's multiplying the mass of an object times the acceleration due to gravity. So the amount of gravity wherever you are, on the Earth, on the moon, in outer space, et cetera, okay? Which is why in outer space where there's no gravity, you can have a mass, right, but you could weigh 0 pounds. So weight, again, is also called the force of gravity. So we measure this in newtons, right? We've learned so far that forces are measured in newtons. Mass is still going to be measured in kilograms. And the acceleration due to gravity is a type of acceleration, so we still measure it in meters per second squared. Okay, so, sorry. Okay, so that's what I want you guys to see here. Again, mass and weight are not the same because mass is the same everywhere. No matter where you are in the universe, it's always the same. But weight can change based on the acceleration due to gravity. So for example, on Earth has a lot more gravity, so you can see this guy's weight on Earth is 560 newtons, which I think is like 140 pounds. Okay, smiley faces if that makes sense. Right, so his weight on Earth is like 140 pounds. Yeah, but when he goes to the moon, his moon weight is significantly less, right? It's like 100, it's like 5, wait, let me see here. Yeah, it's like 5 times less, right? So on the moon, right, his weight is only 92.59 newtons, which I think is like 30 pounds. Again, that's why you can jump super high on the moon. However, his mass is always exactly the same. Okay, can you guys hear me? Okay, good. All right, so gravity is more on Earth than the moon, so you weigh more on Earth, but you're always made up of the same amount of stuff, so you always have the same mass. Okay, same mass, different weight. Now, something important to understand about gravity is gravity does not rely on other forces to exist. It just relies on the fact that things are made of mass. Okay, so since it doesn't rely on any other forces, it's inherent to the universe, right? Which is why we call it a fundamental force. It means that everything that has mass in the universe just inherently has gravity. Okay? Annalise, because why do we measure in newtons and not in pounds? It's because in science, newtons, we don't go over it exactly in class, but newtons actually just makes more sense than pounds. Pounds, they don't have very good like ways to divide out, right? Like the amount of ounces in a pound is 16, right? Whereas like if you think about mass, the amount of grams in a kilogram is just 1,000, or the amount of kilograms in right, it goes up by hundreds. Okay, I know it can be a little bit confusing, but yeah, in America uses very confusing units compared to the rest of the world. So most of the world uses the types of units we're talking about right now because they make more sense. Yeah. Okay, good question. So there are 2 factors that affect gravity. First off is distance. So the further apart you are, the smaller you feel gravity. So for example, if we're close to the Earth, I jump up, what happens? I'm close to the Earth, I jump up, what happens? Tell me in the chat box. Yeah, I come back down, exactly. I jump up, I come right back down. Oh, I'm sorry. Were you asleep? On the other hand, all right, if I'm all the way and I'm about to leave the Earth's atmosphere, as soon as I leave the Earth's atmosphere, it's no longer affecting me as much, which is why as spaceships get further and further away from the Earth, they're suddenly able to float inside of the spaceship, all right, because there's no longer gravity pulling them down to the bottom of the spaceship, okay? Now, again, so, sorry, Annalise, what I'm saying is that, you know, planes, your feet are still on the ground, right? Because gravity's still pulling you down. I'm so sorry. Yes. But a spaceship is so far high up that it's so far away from Earth that your feet no longer touch the ground. Yeah, there is. It's called microgravity. I know. My baby was asleep and then I woke her up. All right. Now, the other thing that matters for gravity is your mass. So remember, you and I all have our own gravitational fields because we're all made of mass, which means everything is attracted to you and me, right? So remind yourself that if you're ever having a bad day, everybody is attracted to you, right? But not nearly as attracted to you as they are to the Earth. okay? Because the Earth has a much, much, much greater mass than you and I do. Okay, smiley faces if that makes sense. Steve, please make sure you're focusing. All right, so yes, Newton's universal law of gravitation, again, gravity is a universal or fundamental force, but it says that two objects always exert a gravitational force on each other. Because everything's made of mass, everybody is exerting gravity on everybody else. Okay? Awesome. So what I want you guys to do now, I want to know which of these is not true about gravity. Use your polling tools. I want to know which of these is not true about gravity. What do you guys think is not true about gravity? Yep, use your polling tools, use your polling tools. Good, getting lots of answers. Awesome. Annalise, do you know where your polling tools are? I just want to double check. Oh, good, I see you just looking good, looking good. All right, got lots of answers. I've got 40 of you, and then right now I've got about 30 answers. So if you haven't answered yet, make sure I get your yes, Ty, I can. Perfect. All right, looks like most of us are saying letter D, and letter D is true. All right, remember gravity is actually lower on the moon, which is why you weigh less, which is why you can jump so high. All right, so give me a green check when you have number 3 saved. Green check when you have number 3 in your ticket saved. I'm going to go ahead and give you guys, all right, looking good. Green checks, please. Andres, Andrew, Annalise, Charles. Sorry, Charles, I feel like, oh, sorry, you got kicked out, but you got back in. Good. Dalen, Emilio, Grant, Jasmine, Jeremy, Melissa, Nadia, Sophia, Stephen. Again, guys, we're working on number 3 in our ticket. Right, link is there and password's there. Perfect. All right, let's keep going. All right, so the last thing is that gravity, okay, like all forces, causes acceleration. It causes a change in velocity. So think about this, right? If you jump off of a little footstool, you don't hit the ground very quickly. Smiley faces, if that makes sense. When you jump off a little footstool, you're not moving very quickly when you hit the ground. Right, on the other hand, okay, if you drop a ball from a cliff or like a penny from a cliff, it can actually drop so fast that by the time it hits the ground, it can actually leave a dent in the ground. Okay, give me a thumbs up if that makes sense. A penny dropped from like your height doesn't put a dent in the ground. But a penny dropped from a cliff is going to put a dent in the ground because it moves much, much faster because it got dropped from a higher height. Yeah, it does. I wonder if I can find a video for it. I should try to find a video and then I can send it to you, Annalise. But yeah, it's pretty crazy. Okay, so again, gravity causes acceleration. It causes things to speed up. So on Earth, the acceleration due to gravity is about 10 meters per second squared. Okay, so the object's going to get faster and faster and hit the ground with more force the longer it has to fall. Yeah, exactly, Elizabeth. Yeah. It can actually, that's why it's really dangerous to throw coins off of buildings because it can actually injure a person below you. Yeah, because it just gets so fast that it hits you with a lot of force. Now, we can see here that what this means is that as time goes on, you can see suddenly my ball is going faster and faster and faster here. Yeah, that's why science is really important to understand, guys, because we learn these things. Don't throw coins off of buildings. Now, without acceleration, objects would hit the ground at the same speed no matter where you drop them from. But again, we know this isn't true, right? Because dropping a penny from a short height doesn't hurt anyone. Dropping it from a high height does. Yeah, exactly, Zoe, right? That's why if you're falling a really, really big distance and you hit the water, yeah, that can actually kill you because it hits so fast that it's actually just like hitting the ground. Yeah, it's pretty crazy, right? So sorry, let's go ahead and finish up here. All right, so the acceleration due to gravity is about 10 meters per second squared. So this means every second our velocity increases by about 10 meters per second. Okay, so if I start dropping a ball, when I first start dropping it, it's not moving at all, 0 meters per second. After 1 second, though, tell me what would be an extra 10 meters per second? Because of this acceleration due to gravity, how fast would I now be moving? After 1 second, tell me in the chat box. How fast would I now be moving? Yeah, I'm going to be moving at 10 meters per second, which is a lot faster. Now, after 2 seconds, an additional second, that's an additional 10 meters per second. What does that equal? 10 plus 10, 10 plus 10. Yeah, I'm going to be moving at 20 meters per second, exactly. And after 3 seconds, how fast am I moving? After 3 seconds, how fast am I moving? Yes, now 30 meters per second. Awesome. Do this matching in number 4. Give me a green check when you have that saved. And then I'm going to wrap us up. Yeah, Annalise, this question is in your quiz. So it asks after a certain amount of time, how much faster would an object be moving? That's why I have this here. All right, waiting on some more green checks. Andres, Andrew, Brianna, Ciara, Dalen, Edgar, Haley, Jake, Jasmine, Melissa, Nadia, Sophia. Looking good. Awesome, guys. Okay, so at this point, again, we should feel pretty good about the types of friction, the factors that affect gravity, and we should know the difference between mass and weight now. Okay, so here's what needs to happen. Make sure you have your attendance ticket answers saved. Don't submit them yet. Okay, don't submit them yet because all of your quiz answers are in the attendance ticket. So I'm going to send you the quiz for today right now, and I want you to take about 5 minutes, do the quiz, all right, while your ticket is still open, and then submit them at the same time. Smiley faces if you understand what you're doing. This is mostly for my new students. My old students know what they're doing. But new students, again, keep the attendance ticket open, have the quiz open, do the quiz right now. It's very short. Get that submitted, and then you guys are all set, okay? So I'm going to go ahead. I'm going to dismiss you guys in a moment so you guys can do that, but you do need your last word for your attendance ticket. That last word is static. Go ahead, enter that, do your quiz, and then I will see you guys later. Have a wonderful day. Let me know if you guys need anything. Bye, everyone. It was great having you today.